Unit 3, Lesson 6. Okay, to start off, go ahead, work on your skills maintenance on page 127 of your workbook. So pause the video and work on that. Alright, now that we're back, okay, graph each of the inequalities on the number line. So when we read this number 1 here, that is saying 99 is greater than or equal to x. Okay, so we're going to go to 99 and we're going to have a closed dot. We have a closed dot due to the fact that it is greater than or equal to. Now, we want to represent those values for x. So if 99 is greater than or equal to x, that means x is also less than or equal to 99. So we can graph to the left. Now, to check your answer again, you can always plug in a value. So let's use 97. 99 is greater than or equal to 97. That is true. Since that is true, that means we graphed to the correct side for this inequality. All right, so number 2, that's saying y is greater than 80. So we go to 80, and since it's strictly greater than, we're going to have an open dot at that 80, and we're looking for values that are greater. Therefore, greater values are to the right. Number 3, that's saying z is less than 133. Since it's strictly less than, we have open dot again. And since it's less than, we go to the values to the left. All right, so that's graphing linear inequalities. Activity 2 on our skills maintenance, simplifying fractions. This is something we will need moving forward, okay, for our rate problems. We have done this before, so when we look at this, 5 and 10, we got to think of a number that goes into both 5 and 10. So when we think about that, we're going to figure out our factors of 5. So what numbers can I count by and get 5? In this case, it's 1 and 5. So I'll start here. Does 5 go into 10? Yes, it does. So I'm going to divide both top and bottom by 5, which will give us 1 over 2. For number 2 there, factors of 3 are 1 and 3. 3 goes both into 3 and 6, so we divide top and bottom by 3, which again will give us 1/2. Number 3 there, okay, smaller number 6, so I'm going to look at my factors of 6. So 1 times 6 is 6, and then 2 times 3 is 6. So those are my factors of 6. Start with 6. 6 does not go into 8. 3 does not go into 8. 2 does go into 8, so we will divide both top and bottom by 2, which will give us 3 over 4. 6 divided by 2 is 3. 8 divided by 2 is that 4. All right, so number 4 there, look at our factors of 12. 1 times 12, 2 times 6, and 3 times 4. So again, always start with the bigger number. 12 does not go into 16. 6 does not go into 16. 4 does. Okay, so there's our greatest common factor. So we're going to divide both top and bottom by 4. 12 divided by 4 is 3. And then 16 divided by 4 is 4. So my simplified fraction is 3/4. All right, finally, number 5, factors of 12 again. 1, 2, 3, 4, 6, and 12. So when we look at this, first start with 12. 12 does not go into 18. 6 does, though. So we will divide both top and bottom by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So my simplified fraction is 2/3. Excuse me. All right, so we will not be able to, we need to be able to simplify fractions when we work on our rate problems today. Now, before we get into those rate problems, let's do a little review. All we're going to do is substitute the given value in for x, simplify that work to write an inequality that is true. So for number 1 here, we're saying let x equal 7. Okay, and we have the inequality -2 plus x is less than 3 plus x. So what we're doing is we're taking that value of 7, and we said x is equal to that 7. So we're going to replace those x values with 7. which is saying negative 2 plus 7, which is less than 3 plus 7. Negative 2 plus 7, okay, now you can think of this as we got 7 positive, 2 negatives. Combining those together, we get a total of 5. 5 is less than 10, which is a true statement. All right, so number 2 there, we got negative 2 for x, so we're going to put negative 2 into there. So we got 4 times negative 2 is greater than or equal to 2 times negative 2. 4 times negative 2, 4 times 2 is 8, and we got a positive times a negative, which will give us a negative value. Is greater than or equal to 2 times negative 2, which is negative 4. So now negative 8 is greater than or equal to negative 4. So think about it this way. Would you rather be $8 in the hole or $4 in the hole? The $4 in the hole is better than the $8 that you would owe someone. So this is a case where this is a false statement. Okay. So in order, well, let's go ahead. Let's make this true. So to make this true, we would have to flip the sign. So negative 8 is less than or equal to that negative 4. Okay, and again, I believe we've talked about this. If we multiply both sides of an inequality by a negative value, we need to flip the sign in order to make that true. Okay, so since we multiplied by that negative 2, you have to flip that sign, because if we don't, that's where we get that false statement. All right, so number 3 there, you got x is equal to 3. So we're going to put 3 in for x. We got negative 6 divided by 3 is less than or equal to 3 divided by 3. Now, we divided by a positive value. Okay, so in this case, we don't need to worry about flipping our sign. Negative 6 divided by 3 is negative 2, is less than or equal to 3 divided by 3, which is 1, which is a true statement. Okay. All right, number 4, let x equal negative 1, and we're doing 7 minus negative 1. Okay, we are not multiplying or dividing by that negative value, therefore we don't have to worry about flipping our sign. Okay, so we got 7 minus negative 1 is greater than or equal to that 2 minus that negative 1. And when we subtract a negative value, that is really saying plus. So we got 7 plus 1 is greater than or equal to 2 plus 1. Okay, we'll go up here. 7 plus 1 is 8. Is greater than or equal to that 3, which is a true statement. All right, so last one here. Multiplying by 3. We got negative 2 times 3 is less than or equal to 3 times 3. Negative 2 times 3 is 6. Is less than 9. And this is a true statement. Okay, so out of those 5 questions, there was only that one problem that we had to flip the sign on. Okay, and that was due to the fact that x was a negative 2. We multiplied both sides of the inequality by a negative value. And when we do that, that's a case where we have to flip the sign in order to make that statement true. Now, on number 4 here, we did have x to be negative 1, but the thing here is we did 7 minus that value. Okay, again, when you're doing this, only when you multiply or divide by a negative value, will you have to flip the sign. All right, so that was how we get inequalities to be true statements when multiplying or dividing by a negative value. Okay, so problem solving for today, we're going to simplify rates. Okay, it's page 128, 129 in the workbook. So let's go to the workbook. 128. So simplify the rates and solve the problems. Kelly bought 6 headbands for $9. Okay, so when we're comparing these two things, we're talking number of headbands $2. Now, in this case, bought 6 headbands for $9. Now, she wants to buy 4 more. How much will it cost to buy 4 headbands? Okay, so when we do this, 4 more headbands would get us to 10. And then we're trying to figure out how many dollars it would be. Okay, and the reason it's 10 is due to the fact that 4 more than 6 is 10. So we need to figure out that cost. So when I look at this, okay, there's no easy way to get from 6 to 10, and there's no easy way to get from 6 to 9. So in these cases, this is where we have to use our simplifying method. Okay, so I need to simplify 6 nines. My factors of 6 are 1, 2, 3, and 6. 6 doesn't go into 9. 3 goes into 9, so I'm going to divide top and bottom by 3 here to get me 2/3. So instead of 6 nines, I'm going to use 2/3. Okay, so this is our simplifying method. Once I simplify, now I have an easy way to get from 2 to 10, which is going to be multiplying by 5. So 3 times 5, we get x is equal to 15. So for this case, x equals 15 is saying that it will cost $15 to buy those 10 headbands. All right, for the next one, Larry bought 8 bags of doggy treats for his pets, and it cost him $20. So we're talking bags, $2, and our initial ratio, we got 8 bags for $20. Now he wants to buy 6 more bags of doggy treats. How much will it cost for 6 bags? Okay, so it's asking for how much it will cost for those 6 bags. And so we got 6 bags, and we're not sure of the price. Okay, so when we look at this one, there's not an easy way to get from 8 to 20. There's not an easy way to get to 8 to 6. So this is a case where we have to simplify, just like we did above. Okay, so we're looking at 8/20ths. Okay, and our factors of 8. Factors of 8, 1, 8, 2, and 4. Okay, so 8 does not go into 20. 4 does, though, so I'm going to divide both top and bottom by that 4 to give me 2/5. Okay, so instead of that 8/20ths here, I'm going to use that 2/5. Now I have a way to get from 2 to 6, which is saying times 3. 2 times 3 is 6. So I'm going to do 5 times 3, which will give me 15. Okay, so how much will it cost for 6 bags? The 6 bags will cost $15. All right, number 3. The day after Thanksgiving, the largest department store in town is having a sale on clothing. 8 pairs of socks are on sale for $12. So we got pairs of socks, $2. And our initial ratio, 8 pair of socks for $12. Now Janine wants 10 pairs of socks. How much will she pay for 10 pairs? So we're going to have 10 on top, and we need to figure out the dollar amount for that. Now again, there's no easy way to get from 8 to 10. There's no easy way to get from 8 to 12. Therefore, we need to simplify that 8/12. Okay, so I'm looking at my factors of 8, which we have above. 8 doesn't go into 12. 4 does, though. So again, dividing by 4, we get 2/3. So instead of that 8/12, we're going to use 2/3. Now I have an easy way to get from 2 to 10. 2 times 5 is 10. So 3 times 5 is 15. So in order to buy 10 pairs of socks, it will cost $15. All right, last one for this page. Huey works for a company that ships products around the world. He loads boxes on a truck. He can stack 12 large boxes on a truck in 15 minutes. How many boxes can he stack on the truck in 20 minutes? Okay, so we're talking boxes to minutes in this case. And he can do 12 boxes in 15 minutes. And we are curious about how much he can do in 20 minutes. Okay, so since we were given the minutes is on bottom, so the 20 will be on bottom. Okay, again, I don't have an easy way to get from 15 to 20 or from 15 to 12. So we are going to simplify our 12/15. So we're going to look at our factors of 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 12 does not go into 15. 6 does not go into 15. 4 doesn't go into 15. 3 does, though. So we're going to divide both top and bottom by 3, which will give us 4/5. So instead of using 12/15, give it 1 second here. Okay, so instead of using that 12/15, we were going to use that simplified fraction, which we said was 4/5. We divided both top and bottom, which was 4/5. Now I have an easy way to get from 5 to 20, which we would multiply by 4. So 4 times 4, which we get 16. So this was how many boxes can he stack? He can box 16 boxes. All right. So moving on to activity 2, we have 3 different strategies for working proportion problems. Look at each proportion, circle the strategy, and then solve the proportion problem. Some of these can be solved with more than one strategy. All right, so let's look at that first one. So I'm looking, can I go from 8 to 12 or can I go from 8 to 4? Okay, 8 to 12 is not going to be easy, so I'm not going to use my vertical strategy. 8 to 4, I can do that. So in this case, we will use our horizontal strategy. And in order to do that, okay, again, we're going from a bigger number to a smaller number, so we're going to divide, and it would be divided by 2. Okay, now you can go the reverse order. 4 times 2 is 8, so that way we know that we got the proper multiplier. Okay, so 12 divided by 2 is 6. So our x value in this case is 6. And we used our horizontal method. All right, so number 2 here, there's not an easy way to go from 7 to 2, but there is a good way to get from 7 to 14. If we multiply both top and bottom by 2. So in this case, we went up and down, which is vertical, and then 2 times 2 is 4. All right, number 3. Okay, no easy, so we're looking, can we go from 5 to 4 or 5 to 15? 5 to 15 would be an easy method. 5 times 3 is 15. So therefore, 4 times 3, we get an x value of 12. In this case, we went from side to side, so our horizontal. All right, so number 4, there's no easy way to go from 4 to 6. There is an easy way to go from 4 to 8. So in this case, 4 times 2 is 8. So to get x, 6 times 2, we get an x value of 12. And since we went from side to side, we used our horizontal method. All right. Number 5 here. Okay, we're thinking 8 to 12 or 8 to 4. I'm thinking 8 to 4 is a lot easier than 8 to 12. Okay, because I know 2 times 4 is 8. So 8 divided by 2 would be 4. So then I would have to do 12 divided by 2. And we get an x value of 6. We went up and down, which is vertical. All right, number 6 then. So I'm looking, is there a nice way to get from 6 to 9 or 9 to 24? I do not know of a good way to do that. So this is a case where we need to simplify. Okay, so I got to look at 9/24. And I got my factors in 9, which are 1, times 9, and 3 times 3. So 1, 3, and 9. 9 is not going to 24. 3 does. Okay, so divide top and bottom by 3. We get 9 divided by 3 is 3. 24 divided by 3 is 8. Okay, so instead of using that 9/24, we're going to use 3/8. Now using that method, I can go from 3 to 6 by multiplying by 2. So 8 times 2, we get an x value of 16. So in this case, we did simplifying and then used our horizontals. So we had to use multiple strategies for that problem. All right, that is lesson 3. Oh, sorry, lesson 6. Okay, so your homework for this lesson is lesson 6. If you have questions, make sure you ask. Otherwise, have a good day.